today we will discuss a PRE-PSPM paper on chapter 1 method. So the first question, define relative atomic mass of an element. So definition of relative atomic mass is the mass of one of its atom relative to 1/12 the mass of one atom carbon-12. The second Roman, a sample of chlorine consists of two isotopes, 3517Cl and 3717Cl. The relative atomic mass of chlorine is 35.5. So determine the percentage composition of each isotope in the sample. So we can calculate the percentage by letting 35Cl17 equals to X and 3717Cl equals to 100 minus X. And then we can calculate it by using the formula Kmi over K. And then we just need to substitute the isotopic masses in the formula, and then we will get the answer is 35Cl is 75% and 37Cl is 25%. Next, we will go to question B. A compound CC contains carbon, hydrogen, and oxygen. A 0.2 gram sample of CC was burned completely in a combustion train to yield 0.3906 gram of CO2 and 0.2025 gram of H2O. In a separate experiment, the molecular mass of CC was found to be 90. What is the empirical and molecular formula of CC? So first of all, we need to write down all the information given. So mass of CO2, mass of H2O. So first of all, we need to write down all the information given. So mass of CO2, mass of H2O, and the molecular mass. And then first step, we need to calculate moles for each compound. So CO2, we will get 0.008877 mole CO2, and then moles of H2O, 0.01125 mole of H2O. Next, we will calculate the mole for each element. So for C, that contained in the CO2, so we need to do the stoichiometry ratio. So we will get the mole for C is 0.008877 mole C, and the mole for H is 0.0225 mole of H. So in each CO2 compound, it has 1 mole of C, and in H2O, there are 2 mole of H. So next, to find the mass for each element, we just need to multiply the mole that we get with the molar mass, and then we will get the mass of C and H. After that, we can calculate the mass of oxygen and the mole of oxygen. And then we need to create a table that contains the mass of each element, the mole, simplest mole ratio. So after we calculate, we will get the empirical formula for CC is C2H5O. And then the question asks us to calculate the molecular formula. So we just need to time the empirical formula with N equals to the total of molar mass. And then we will get the molecular formula for CC is C4H10O2. Next, the question C. Density of an aqueous solution containing 10% of ethanol, C2H5OH, by mass is 0.984 gram liter. So first Roman, calculate the molality of the solution. So percentage by mass of ethanol is 10%. So percentage by mass can be calculated by mass of solute over mass of solution times 100. So we can assume the mass of solution is 100 gram. So we just need to multiply 100 gram with 100, and then we will get the mass of solute is 10 gram. Okay, and then after that, we can calculate the moles of solute. So by using the formula mass over molar mass, so 10 gram of ethanol divide with the total of the molar mass for ethanol, and then we'll get the answer is 0.2174 mole of C2H5OH, which is the ethanol. And then we can find the mass of solvent by using this formula, mass of solution equals to mass of solute plus mass of solvent, and then the answer is 90 gram. So now we can calculate the molality, which is mole of solute over mass of solvent. So 0.2174 mole over 90 gram, but we need to remember that the unit for the mass of solvent need to be in kg, so we need to convert it. Molality for ethanol will be 2.416 mole kg negative 1, or you can just write it as small letter of m. And then we will go to the next question. Calculate the molarity of C2H5OH. So first of all, we can find the volume of solution by using the formula density, and then we'll get the volume of solution is 101.626 liter, and then we calculate the molarity by using the formula N over V. So we will use the mole from the previous question, divide with the volume of solution. We will get 0.002139 m. Next, the last question. An impure solid sample of iron is reacted with an excess of hydrochloric HCl to form an aqueous solution of iron chloride, FeCl2 and H2 gas. Assume that the impurities do not react with HCl. So first, write a balanced equation for the reaction. So the balanced equation is Fe, S for solid, plus 2HCl aqueous will produce FeCl2 aqueous plus H2 gas. Next, 0.274 gram of the impure iron is reacted with an excess of hydrochloric acid, and amount 8.54 times 10 power of 3 gram of H2 gas is evolved. Calculate the percentage of iron in the sample. So first of all, calculate the moles of H2. So 0.00427 mole of H2, and then we will do the stoichiometry ratio. So 1 mole of Fe will produce 1 mole of H2. So we will get the mole for Fe is 0.00427 mole of Fe, and then we will calculate the mass of Fe. So we will get 0.2387 gram, and then the percentage of Fe is 87.11%. So that's all from me. Thank you.